Hi everyone, welcome to Abhijyati Mathematics Only. Many of you guys know that all my videos are based on mathematics. So before starting today's topic, if you have not yet subscribed my channel, please subscribe my channel and press the bell icon to get notifications for all of my upcoming videos. I'll try to give answer for all of your questions, so watch the video till the end without skipping. And if you have any questions about today's topic, please comment me. Let's start today's video after a little in. Hi everyone, my today's video is based on mapping, which is also called function. And first of all, to learn about mapping you have to know the definition. The definition of mapping is: let A and B be two non-empty sets. A mapping A from A to B is a rule that assigns to each element X of A a definite element Y in B. Okay, as you can see that X is a set and Y is a set, we can write Y as fx, where f is the mapping. A maps to E or F, B maps to G, C maps to F, or they can map, B can map to E. It can be happen. Okay, so about mapping, you have to know about the injective mapping, surjective mapping and bijective mapping. It is very important for your HS. Injective mapping. A mapping F such that it tends to be said to be an injective mapping or one-to-one mapping if for each pair of distinct element of A their F images are distinct. Surjective mapping. A mapping F such that it tends to be said to be a surjective mapping or onto if fa is equals to b. And bijective mapping. A mapping F such that it tends to be said to be a bijective mapping if f is both injective and surjective. Okay, and now I am going to tell you about onto mapping, which is not so important but including in your syllabus. A mapping F such that it tends to be said to be a onto mapping if fa is equals to b. In this case we say that it maps A onto B. Okay, now I am going to tell you about an example. Let f such that real number tends to real number be defined by fx is equals to 3x plus 1, x belongs to real number. Prove that f is bijective. So for proving bijective we have to first let it injective and second surjective. Okay, let's start. Let us assume two distinct elements x1 and x2 in R. Fx1 is equals to 3x1 plus 1 and fx2 is equals to 3x2 plus 1. If x1 minus fx2 is equals to 3x1 plus 1 minus 3x2 minus 1 is equals to 3 into x1 minus x2, which is not is equals to 0. Since x1 not is equals to x2 implies fx1 not is equals to fx2, so f is injective. Now let us take an arbitrary element y in the set R, then codomain of f, and let us examine if y have a pre-image x in the domain of f, then fx is equals to y and 3x plus 1 is equals to y. This implies x is equals to y minus 1 by 3. Since y belongs to R and y minus 1 by 3 belongs to R, therefore y has a pre-image y minus 1 by 3 in the domain of f. Since y is arbitrary, each element in the codomain of f has a pre-image, so f is surjective.